This is R.D. Sharma's solution. We are taking chapter number 16, Tangents and Normals. Exercise is 16.3. Now this question, because it is the start of the exercise, you have to understand this question very carefully. There are two curves, and what is the concept of angle between two curves? See, first thing is that you can draw a tangent on this point. When you draw the tangents at this point to these two curves, the angle between the tangents will be the angle between the curve. That is the whole concept of this exercise and this question. How do you do that? See, first of all, you have two curves. You have to find the intersection point. For that, you have to solve these two curves. Let us solve it. X square is y and x is y square. So either you can put x as y square or y as x square in any of the equation. The main idea is to solve for x and y. So I am placing y square in place of x, and we get y raised 4 minus y equals to 0. So y you can take common. It will be y cube minus 1 equals to 0. So from here you get y equals to 0. From here you will get y equals to 1. If you put y cube is equal to 1, y will be cube root of 1, which is going to be 1 only. Now at y equals to 1 and y equal to 0, you can find out the value of x corresponding x. So y square is x, and you have to see that whatever value comes has to qualify both the equations. So when you put y equals to x, x will be equal to 0 in both the equations, and when you put y equals to 1, x will be equal to 1 in both the equations. So we have two coordinate points, 0, 0 and 1, 1. That means this curve is not only intersecting, they both are not intersecting at one point, but multiple points. And here in this case we see 2 points. So 2 points of intersection. So there will be 4 tangents, that is pair of tangents at 2 points, and 2 pair of angles. And let us see those angles are equal or not. Probably they will be equal. So we have the first equation as y square equals to x. So we are trying to find out the slope of the tangent now. This is 2y divided by dx. Divided by dx is equal to 1 by 2y. The second one is x square equals y. Just differentiate it. 2x equals dy by dx. One time we got dy by dx is 1 by 2y. One time we got dy by dx as 2x. So first is at first location 0, 0. What will be the slope of the first tangent and the second tangent? So this is case 1, we will take 0, 0. This is case 2, we'll take 1, 1. So case 1 and case 2 will put x and y as 0, 0. So what will be dy by dx? 1 by 2 into 0. That is 1 by 0. That is infinite. And slope infinite means we are talking about a line which is parallel to y-axis. And here 2x will be, see, x is 0. So dy by dx is equal to 0. So this is one line. Dy by dx equals to 0. I'm talking about a line which is perpendicular to the x-axis. That is the only thing, only angle will be pi by 2, which is tan pi by 2 is infinite. So theta is pi by 2 in this case. Then the second one, case 2, will put x and y as 1, 1 in both the slopes. What are the slopes? 1 by 2y and 2x. So 1 by 2y, 1 by 2 into 1. This you can call it as m1, which is the slope, first slope. How about the second slope? dy by dx is equal to 2 into x. So just put x as 1, 2 into 1. So the second slope or the line, second line having a slope of 2. When you have m1 and m2, there are two lines, two slopes. How are we going to find the angle between them? So the angle between two lines is tan theta equals m1 minus m2 by 1 plus m1 m2. And please remember, we have to take the modulus. Even if it comes as negative, you have to make it as positive. We have the modulus, very important thing, and we have for this question m1 equals half and m2 equals 2. Just put it here. Half minus 2 divided by 1 plus half into 2. Half minus 2 is 1 minus 4 by 2. That is negative 3 by 2. This denominator 2 gets cancelled. 1 plus 1 is 2. So you have 2 in the denominator. You have negative 3 by 4. So this is your tan theta. So first theta was pi by 2. The second theta is tan inverse 3 by 4. And please remember, you have to always take modulus. So it is not minus 3 by 4. It will only be 3 by 4. Please remember. No negative, because modulus will be there. Now let me show you the actual reference who wants to solve by themselves. Just to check question answer, this is the reference for you. So there are certain questions will follow, and those which are equivalent, we'll just leave them. The second question is y is equal to x square and x square plus y square equals to 20. The thing is, first we have to find out the intersection points. There are two curves, there will be intersection points. So y is equal to x square and x square plus y square is equal to 20. Just combine these two and try to find out the value of x and y here. Y is equal to x square. You can call it as x square equals to y. So you can put x square as y in the second equation. It will be y plus y square equals 20. You will get a quadratic equation, and that will give you certain roots, and those roots will be y points, and corresponding x points can be computed. So I'm placing x square as y. So y plus y square equals 20. You can just rearrange this equation to form y square plus y minus 20 equals to 0. Y square plus y minus 20 equals to 0. 20 is 5 4s are 20. So possibly you'll get 5 and 4 in some negative positive. Let us find it properly. So y plus 5 minus 4 y plus 5 is equal to 0. It's y minus 5 and y plus 5 y minus 4. Sorry. Y plus 5 equals to 0. So you'll get two roots. Y equals to 4 one time, y equals to negative 5 one time. 4 and minus 5 here. Now in any equation you can put, because corresponding value of x also has to compute it, because y is x square is equal to 4, x will be equal to plus minus 2. So one case you get x equals to plus minus 2, that is for y equals to 4, one time you get x is equal to 2, so the coordinate points will be 2 and 4. Next time you will get negative 2, so the coordinate points will be negative 2 and 4. How about y equals to negative 5? X square is equal to y, that is negative 5. So this is not done, because under root negative 5 will not be a real value, it will be a complex value, and we are not dealing with the complex value, so we'll just leave it. We'll just write it that we don't find any real solution. So we are only left with 2 and 4 and negative 2 and 4. Those are the coordinate points at which these two curves, they actually intersect. So we have to find out the slope of the tangent. So in order to find out the tangent, you have to find out dy by dx, which is the slope. So dy by dx, first curve will be m1, second curve will be m2. So I am talking about two curves which are intersecting at 2 points here. One point is 2 4, one point is negative 2 4. So we are try and find the slopes here of the tangents, and then find out the angle between them. So I am differentiating the first one. Second one, y is equal to x square is the first equation of first curve. The second one is x square plus y square equals to 20. I am differentiating it. Dy by dx will be equal to 2x. Here we have x square plus y square equals to 20. So let us differentiate it again. You get 2x plus 2y dy by dx is equal to 0. 2 you can cancel. X plus y dy by dx equals to 0. So dy by dx will be negative x by y. So the first slope will be computed at 2x. The second slope will be computed at minus x by y. So I'm taking case 1. First we'll use the coordinate 2 and 4. Second we'll use the negative 2 and 4. So just put this values and find out m1 and m2 in both the cases. So here m1 will be 2 into x, 2 into 2, that is 4. This is x and y. m1 is 4. What is m2? m2 will be negative x by y. So negative 2 by 4. It is minus half in this case. m1 is 4, m2 is minus half in the first case. The second case, m1 will be what? 2 into 2. No, 2 into negative 2, because we are taking negative 2 and 4 here. So it will be 2 into negative 2, that is negative 4. And then m2 will be negative x by y. So you have to take negative 2 and 4 in this case. So negative will become positive. Let us write it here. It will be half. Okay. So m1 and m2 is now known to us. Tan theta is what? m1 minus m2 by 1 plus m1 m2, and as I suggested earlier also, you have to take the modulus. It will always be positive. Even if it is negative sign, you have to take it as positive. Alright. So tan theta will be what? m1 minus m2 by 1 plus m2. 1 plus m1 m2. So 4 minus or minus half, 1 plus 4 into negative half. And this will be the first angle between two lines and at the first point. At second point, tan theta will be negative 4 minus negative half, 1 plus negative 4 into half. So when you solve it, you will get 9 by 2. Here also you will get 9 by 2, and that has to come because these two lines, whatever angle they are making, they'll make the same angle. Okay, so at tan inverse 9 by 2, tan inverse 9 by 2 is the angle in both the cases. So this is the whole procedure. Now let me show you the reference also, the reference solution. So this you have to follow, and please remember, always take the modulus. It may come negative, it may come positive, it should always come as positive. So I hope this question can be done by you, because two questions we have done, and most of the things we have discussed. So this is the whole procedure you have to follow. This is the reference solution for you. Now this question seems a bit different. So the first step which everyone has to follow, I'll start with that and see where we land up. So I am going to solve these two equations, because the angle of intersection of these curve can only be found when we have the point of intersection of the curve. We have x square plus y square. You can write it as 4x plus 1, and this x square plus y square, which is 4x plus 1, can be put in the second equation. or I'm just saying that this x square plus y square, which is 4x plus 1, can be put in here. Minus 2y minus 9 is already there. So you get a formal equation of a line, and that line will say what? You'll just see. But you can do one more thing. You can put x square plus y square, which is 2y plus 9, in the first equation. In place of x square plus y square, you can put 2y plus 9. I'll just show it to you. I'll just show it to you and convince you that either way you replace anything from in first equation to the second equation or vice versa, you are going to find out the same equation of the line. So what do you get? Same thing I'm doing, means for both the equations, I'm trying to put value of x square plus y square from first to second and second to 1. And when you solve this, you'll get 4x minus 2y minus 8 equals to 0. Both the equations are same. Both the equations are same. And you can minimalize it, or you can simplify it by dividing it by 2. You'll get 2x minus y minus 4 equals to 0. That is the equation with what we got. As I said, you can simplify it for your easier computation. So 2x minus y is equal to 4 is your, or you can call it as y equals to 2x minus 4. Now y equals to 2x minus 4. This you can put in any of the equation. So I am putting y equals to 2x minus 4 in the first equation, x square plus 2x minus 4 equals whole square minus 4x minus 1 equals to 0. So I am not going to solve this. This is a very simple quadratic equation that you have solved multiple times. So you'll get roots, which is x equals to 3 and x equals to 1. Now put x equals to 3 and x equals to 1 in any of the equation. When you put x equals to 3, you will get y is equal to 2. Here also, when you x equals to 1 in any of the equation, y will be equal to negative 2. So I'm not solving this equation. I'm just leaving it for you, and I hope the quadratic equation can be solved by you in no time. Now we have 2 points, 3 and 2 and 1 and negative 2. So first equation, second equation, we have to differentiate. That is, I'm differentiating in order to find out dy by dx, because we got the point, we need dy by dx. So 2x plus 2y dy by dx minus 4 equals to 0. The second equation differentiation will be 2x plus 2y dy by dx minus 2 dy by dx is equal to 0. Now in both the cases, we have to find out dy by dx. And dy by dx, that is the slope, which is essentially the slope only, right? So I'm just rearranging it to get the dy by dx. Let us see it. Dy by dx will be equal to 2 minus x divided by y. Here dy by dx will be equal to, again I'm just rearranging it, okay? Nothing else I'm performing. I'm just doing rearrangement. You will get dy by dx is 2 minus x by y in the first case. In the second case, you will get x by 1 minus y. Now you have 3, 2 and 1 minus 2. So I'm making it as case 1 and case 2. Case 1, you will take x as 1 and y as 2. Case 2, you will take x as 1 and y as negative 2. So this is M1, this is called M2. So what will be M1 in this case when you put 3 and 2? 2 minus 3 divided by 2 it will be. So you get minus 1 by half as the first law, minus half. How about M2? M2 will be 3 and 2 has to be put in the x by 1 minus y. It will be 3 by 1 minus 2. So it will be negative 3. In case 2, same thing. 1 and negative 2 you have to put. M1 as, so we get 2 minus 1 divided by minus 2, 1 minus 2. So just minus half. So now you have M1, M2 for case 1, M1, M2 for case 2. And that is going to be, so M1, M2 in both the cases, tan theta 1 and tan theta 2. So there will be two angles. M1 minus M2 by 1 plus M1, M2. Just use that formula. M1 is negative half, M2 is negative 3. And take the modulus, please. Tan theta 2 will be minus half, minus 1 by 3, 1 plus negative half into 1 by 3. So it will be 1. This is going to be tan theta 2, again 1. So you have to take the modulus. Even if it is negative, you have to put it as positive. So previous question also we got 9 by 2, if you remember. So theta is tan inverse 1 in both the case. But tan theta is 1 is what? Theta has to be pi by 4, 45 degree. So theta is pi by 4. This is your answer. Okay, 45 degree. Now let me show you the reference solution, because this is how we are going to follow it. The concept remains the same. This question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.